Let's talk about the fourth defining property of waves, which is interference. It is when waves are approaching each other and overlap in the same space and time on the medium. So this is when the waves meet and they combine, and as you saw in the video demonstration, they pass through each other as if nothing happened. That's really one of the most important parts of interference. All waves can exhibit this property because they're pure energy. Energy really goes through to their intended destination. So let's look at the two different types of interference. First, constructive, which you saw in the video, that's when the amplitude got larger. So let's officially define that as the combined amplitude is larger than the originals. They build on top of each other, literally constructing a larger amplitude. And so for the before picture, let's draw the waves on a string or the slinky approaching each other. So let's say I was creating a 3 centimeter amplitude wave and my daughter was creating a 10 centimeter amplitude wave, and they're approaching each other. The during picture is going to be at the moment they overlap. So I want you to pause the video and draw what you think the waves look like at the moment they overlap, including the size of the amplitude. How large can the amplitude be? Well, if you took a guess, I hope you guessed about 13, and that's absolutely right. So the math here is real simple. They literally just add together as a 13 centimeter tall amplitude. In this case, both crests form a single crest. Notice there are no arrows on this picture, and that's really, really important because this picture at the during is really just a snapshot, this one moment in time when they overlap each other. In the before picture, they're certainly in motion. The during is just one moment in time. If you were to put arrows on it, that would indicate that they're moving one way or the other, and that's not what really happens here, right? This is when you try to pause the video at that moment they overlapped. Now in the after picture, go ahead and draw what you think happens there. This is the whole idea. They pass through each other as if they never even met. And so the 3 centimeter pulse continues on its way, and the 10 centimeter pulse continues on its way. Here we do put the arrows because we are showing what happens afterwards, that they are in motion. Then we get to destructive interference. This is when I flip my wave over to the other side, and you saw when they overlapped, they made something smaller. But the real way to define this is that the combined amplitude is smaller than the largest original. That one amplitude gets completely or partially destroyed by the other. And again, I did this by flipping, for example, my wave over. So my daughter still made her 10 centimeter amplitude wave, and I flip mine over to a trough as 3 centimeters, and then pause the video and draw what you think the string or the slinky looks like in the during phase. So if you had to take a guess what the amplitude is, hopefully you guessed 7 centimeters, but which is it, a crest or a trough? Well, hopefully you see, of course, the crest is the larger one, and so it's going to be a 7 centimeter crest. So the 3 centimeter trough literally subtracts away from the 10 centimeter crest, and who wins? It's the crest, right? Notice again, there's no arrows on this picture because it's just a snapshot, a moment in time when they overlap each other. And then go ahead and pause the video and draw what you think happens in the after situation. So once again, the waves continue on their way as if nothing ever happened. So the 3 centimeter trough continues, the 10 centimeter crest continues, as if they never even met. This is known as partial destructive interference. Now, you don't have room on your page to draw this, so you can just watch, but let's say I get a little jealous and say, oh, my daughter made a 10 centimeter amplitude wave, I can make a 10 centimeter amplitude wave as well. Just think it through. What do you think the medium would look like at the moment they overlap? Well, hopefully you realize it should look flatline, right? This is complete destructive interference. The two waves completely cancel each other out. Now, what should this look like in the after situation? Well, once again, almost as if by magic, the waves reappear as if they never even met. And that's a really, really important aspect of interference, that the waves pass through each other as if they never even met. Continue in your handwritten notes. Let's just put this all together by saying that all waves show all these properties. So we want to say it like this. For something to be considered a wave, it must exhibit all 4 defining properties. These are the defining properties of waves. So it's almost like you could use these as a series of tests. If you're looking at some phenomenon, if you're not quite sure if it's a wave, you can go through these 4 properties and see, does it check off all of them on the list? And if so, it's a wave. If it misses even one, it's something else. It's something that has some of the same properties of waves, can be described by waves, but itself is not a wave. This is a rather large concept. We're going to go right ahead and make this a big idea.